Phew. All right. Geometry in is May 18th on a rainy Monday morning. I've got 17 days left of school. That's approximately 3 weeks. That's it. You got about 2 weeks of instruction left for me, so get some of those things, assignments in, please. This is called dilations, D-I-L-A-T-I-O-N-S. It is related to translations and transformations on the coordinate plane. These are your notes. You are to turn in your notes in the Google Classroom app for half credit, half of the assignment's credit. A dilation is a transformation in which a figure gets bigger or smaller. Second fact, every dilation has a scale factor. That's abbreviated by SF. So the scale factor, basically we're going to have a figure either get bigger or smaller, and it's up to that scale factor on whether it gets bigger or smaller. You will understand it in the examples. Okay? The scale factor is used to dilate an enlargement, which makes it bigger, or a reduction, which makes it smaller. Enlarge means to get bigger, reduction or reduce means to get smaller. All right? You are going to need some graph paper here. You may want to press pause on that space bar to slow this down a little bit. This is going to be just like your homework problems. Exact same setup. You're going to have 2 of each. What this says is graph M, N, P, Q, and M prime, N prime, P prime, Q prime after dilating with a scale factor equal to 3. So the first thing we're going to do is we're going to look on this coordinate plane and we're going to jot down the coordinates for M, N, P, and Q. This should be an easy review for you guys. M, the coordinates would be -1, -1. N, the coordinates would be, if I'm starting at the origin, right 1 and down 2, which is 1 and -2. P is right here, that would be right 1 and up 2, which would be 1 and +2. And Q is left 1 and up 3, which is -1 and +3. This is getting bigger. The scale factor is 3. Here's how we do this. I'm only going to do one example. I'm taking this scale factor of 3 and I'm multiplying every single one of these coordinates by 3, okay? And I'm going to show my work here. I'm just putting a .3 all the way down. And I'm putting lines underneath of these. This is very simple multiplication. Here we go. -1 times 3 is -3. -1 times 3 is -3. I'm enclosing that in parentheses. These coordinates become my M prime. So all of these are going to be multiplied by the scale factor. 1 times 3 is 3. -2 times 3 is -6. I'm putting them in parentheses and I'm labeling this coordinate N prime. 1 times 3 is 3. 2 times 3 is 6. I'm labeling this coordinate as P prime. -1 times 3 is -3. 3 times 3 is 9. I'm labeling this as Q prime. So sorry if, let me just zoom this in a little bit and check this out. So just to review, I took MNPQ, I multiplied every single number on here by that scale factor of 3. Remember, a negative times a positive is a negative. And if it was a negative, times a positive, it's a negative, and if it's a positive times a positive, it's a positive. So there's m prime, n prime, p prime, and q prime. I am now going to plot these 4 coordinates and label them. M prime, -3, -3. Left 3, 1, 2, 3, down 3, 1, 2, 3. There is my m prime coordinate. N prime is +3, -6. 1, 2, 3 to the right, down 1, 2, 3, 4, 5, 6. There is n prime right there. P prime, right 3 up 6, 1, 2, 3, up 1, 2, 3, 4, 5, 6. I'm putting my P prime right there. And my Q prime is -3 up 9. You gotta improvise on this one. Left 1, 2, 3, up 9 would actually be a little bit above that graph, and that's okay. If you have graph paper, it's not going to be a problem. Now I'm connecting my dots. It's a very large parallelogram, and there it is. We went from this image, we dilated it with a scale factor of 3 and basically made it bigger. It's very similar. It's a similar shape. It didn't change shape. It's the same thing, it just got bigger. Okay? And that's it for the enlargements. Same thing on the reductions. We're going to move down for example 2 on the notes. I have A, B, and C, and I'm going to find the coordinates for these. Once I do that, I'm going to apply a scale factor of 1/3. Because it's a fraction, I'm going to know that that's going to get smaller. I'm going to divide everything here by 3, okay? I'm going to look at this coordinate and go, I'm just going to fill it in and go, A is -3 and 6. B is 3, 0. C is -3, 0. I'm dividing all of these numbers by +3, divided by 3, 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 and divided by 3. My answers here are -1 and 2. That is my A prime. 3 divided by 3 is 1. 0 divided by 3 is 0. Those coordinates are my B prime. -3 divided by 3 is -1, and 0 divided by 3 is 0. I am making that C prime. Now I'm going to plot these 3. This is going to go from here, this right triangle, it's going to be the same shape, except it's going to be a little bit smaller. A is -1, 2. -1 up 2. There is A prime. B is 1, 0. Over 1 up 0, it's right on the line. I'm going to squeeze a little B prime in there, and C is -1, 0, which is right there. So I've got A prime, B prime, C prime. I will zoom that in. It just got a little bit smaller. So this is straightforward. If you can look at, let me just show you what's going on here. You are doing 1, 2, 3, 4 of these. On your homework, it's the same thing. I set it up, okay? You're getting me the coordinates for W, X, Y, Z, and A, B, C, D. You're going to write them here. You're going to multiply all of them just like I did up here on example 1, okay? And you're going to give me their prime notation of the new coordinates. These are going to get bigger. The ones on the back, these are going to get smaller. This is a big one on the outside, okay? This is your shape. You're dividing all of these by 8. You're dividing all of these by the bottom number here on the fraction, which is 3. So give me the coordinates, divide it, and give me the new ones, okay? I think it's pretty straightforward. Let me know if you have any problems. Alrighty? That's all I got. Have a good one.